Let us do another problem of Euclid's division lemma. The question is here. Use the Euclid's division lemma, or else we can suggest to use the Euclid's division problems. To show that square, here we are doing square problems, square of any positive integer is of the form 3m or 3m plus 1. So this is the problem about the square 3m or 3m plus 1. Instead of p, you can get m, instead of m you can get p also. P, q, any variable you can get. So here we are using m based on the question. Let us start doing this. Always you have to write the Euclid's division lemma problems. That means definition you have to write as per Euclid's division lemma. As per Euclid's division lemma, a and b are positive integers. B are positive integers. There exist, you can write there exist Q and R such that A is equals to BQ plus R for 0 less than and equal to R and less than B. Whenever you get the questions in this form, always you have to start from this. You have to write in all the problems, you have to write this. Then what is there we have to prove? We have to prove the answer in the form of 3m or 3m plus 1. You have to prove the square of any positive integers. To prove the square of any positive integers, first we will prove positive integers. So can you tell me what are the squares? Squares, 1 square. Applying 2 as a power is called a square. So 1 square is 1 ones are 1. 2 square is 2 into 2, 2 twos are 4. 3 square is 3 into 3 is equals to 9. So these are the squares. So you have to prove the these answers 1, 4, 9, after 9, 4, 16, 25. These are the positive squares. 4 square is 16. 5 square is 25. These are the squares. These squares comes in this form 3m or 3m plus 1 in the method of Euclid's division lemma. So let us start doing this. Instead of square, first we will do the positive integers. Let a be positive integer. Positive integer and b is equal to 3. Here we are taking b as 3 because it is given b 3. But in the cubic questions, what we have done? In the cube it is given 9m plus 1, but we have taken a as a positive integer, but b is equal to 3 we have taken in the cubic form, because 9 is there in the question. 9 if you multiply it with 3, you can get cube. 3 into 3 into 3. 9 3s are 27. 27 is a cube number. But here just we are taking same as it is. B is equal to 3 and a is a positive integer. So what are the remainders? 0 should be less than and equal to R and less than B. B is 3 here, so write 3. What are the remainders? Remainder is greater than and equal to 0. So 0 will be there, 1 will be there, 2 is there. We will not include 3 because remainder is less than 3. So 3 we are not including here. Now you have to solve for these 3 cases. Remainder 0, remainder 1 and remainder 2. Now let us do for R equals to 0. For remainder R equals to 0, A is equals to 3q plus R, that is A is equal to 3q plus 0. No, just simply directly we can also write A is equal to 3q. What about remainder 1? R is equals to 1, A is equals to 3q plus 1. What about remainder 3? Remainder 2? A is equals to 3q plus 2. So these are the three cases we have. So these are the positive numbers. A is a positive integer. So a is 3q we got, a is equal to 3q plus 1 we got, and a is equal to 3q plus 2 we got. These are the nothing but positive integers, right? Integers means anything. Suppose if I take q is equal to 1, a is equal to 3 1s are 3. 3 is a positive integer. What about this? A is equal to 3. If I take q as 1, 3 1s are 3 plus 1 4. 4 is a positive integer. Here also if I take q as 1, 3 1s are 3 plus 2 5. 5 is a positive integer, right? 3 4 5. So a is nothing but it is a positive integer. But after that we have to prove square of any positive integers. So let us do for it. First we will take a is equal to 3q. This one we will take, right? Using this, actually what we have to do, we have to prove the square of any positive integers of the form 3m or 3m plus 1. In the previous textbook I have seen the question written is wrong. The question is 3m plus 1 or 3m plus 2. But this is not the correct thing. Some textbook the question is given wrong. So don't go through this. Only the question is you have to prove only for 3m or 3m plus 1. So let's do for the first one, case 1. That is first one we are taking a is equal to 3q, squaring on both the sides. Now here we are applying square. Why? Because we have to prove the question the square of any positive integer. So we are applying square on both the sides. A square is equal to 3q whole square. That is it should be in this form now. So 3 square means 3 into q square. 3 into this we will write it as m. 3 square means 3 into 3. Q square as it is we are writing. 3 we are taking it common, and 3q square we are writing as m, where m is equals to 3q square. It is some integer, it is some positive integer. M is equal to 3q square. So we got the first one 3m. Using the first case remainder 0, we got a is equal to 3q as a positive integer. Using that we have to prove square. So we have applied square here. Squaring on both sides, we got a square is equal to, we have solved, we got the answer 3m. So first one is finished over here. Now let us do for the second case, that is 3q plus 1. Now we will do the second case, a is equal to 3q plus 1, right? Squaring on both sides. A square is equal to 3q plus 1 whole square. We are applying square here. What we have to do then, this is a plus b whole square form. A plus b whole square form. That is a square plus 2ab plus b square. I think everyone knows this identity. A plus b whole square equals to a square plus 2ab plus b square. This identity we are going to apply over here. In the place of a we have 3q. In the place of b we have 1. So using this identity, let us do. So what is it? A is nothing but 3q. Is it 3q or 1? A. We can replace also. If you change also, no problem. Same thing we will get because it is a plus sign, positive number, a plus b. So anything we can take, but simply as it is we are using. A is 3q whole square plus 2 into 2ab means 2 into a into b. 2 into a is 3q into b is 1 plus b square is 1 square. 3q square means 3 into q square. I am writing 3 square means 3 into 3, q square as it is. We are removing the bracket, applying 3 square and q square. So 3 square is 3 into 3 plus, here no need to multiply because we have to take 3 common. In the question we have to prove this 3. So 3 we are taking it common. 2 1s are 2, 2q plus 1. 3 into 3q square plus 3 into 2q plus 1. Now what is it? We are taking 3 common here. 3 common here, 3q square plus 2q plus 1. Now is it proved? No. Still we have to do one more step. That is 3 into this. This is now one term. 3 into this. this we can write as m. 3 into m, completely this bracket we are writing it as m. 3 into m plus 1 as it is. So now we got square of a square. Square of any positive integer, it comes in the form of 3m plus 1. So we got the answer 3m plus 1, right? A square is equal to 3m plus 1. What about m? M is nothing but, just we are writing m as this term. Completely this we are writing as m because we have to prove it. M is equal to 3q square plus 2q. It is some integer. So we got it. But we can stop here also. But because remainder 2 is also there, we can do for remainder 2. Now using remainder 2, already we got the answer. Answer is finished over here. So square of positive integer comes in the form of 3m or 3m plus 1. But because remainder 2 is also left, we can do for remainder 2 also. A is equal to 3q plus 2. We are doing for a equals to 3q plus 2. A is a positive integer. Apply square on it. A square is equal to 3q plus 2 whole square. Now again it is in the form 3q whole square plus 2 into 3q into 2 plus b square 2 square. Understood this step? Same thing we are applying here, that is a plus b whole square. A square 3q square plus 2 into ab multiplication. 2 into a is here 3q into b is 2 plus 2 b square, b here is 2 square. Now 3q square means 3 into 3q square, 3 square we are applying for 3, so 3 into 3, q also gets square, q square we are not splitting, we are writing as it is, plus again 3 we are taking out common because we have to prove in this form. 3 into 2 to the 4 q plus 2 square is 2 into 2 to the 4. Sometimes the students will do wrong calculations. Suppose if I write some students 2 cube means they will write 2 into 3, 2 3 is 6. This is the wrong thing. 2 cube means 2 into 2 to the 4 2, right? I'm just this is not there, but I just want you to understand these things. 2 square is nothing but 2 into 2. Because 2 square 2 into 2, students will do this. 2 cube means 2 into 3 they will do. This is the wrong way. 2 cube means 2 into 2. So here I am writing 2 square means 2 into 2 in this way, okay. So we got 4. But can we split 4? We can write 4 as 3 plus 1. Why I am taking 3? Because we have to take 3 as common here. We have to get the answer in this form. So I can split 4 as 3 plus 1. 3 into 3q square plus 3 into 4q. Same thing you write. Plus 4 we can write as 3 plus 1. Right. Now after this what we have? We can take one more 3 common from here. So that's why we can split 4 as 3 plus 1. Now here this is 3 into 3q square plus 4q plus 1. See, we are taking 3 common from here, 3 common from here and 3 common from here. So the last one is 3 ones are 1 we have tried. 3 ones are 3 plus 1. Now this we are writing as 3 into m plus 1. Have you seen the answer? Again we got 3m plus 1. 3m plus 1. It is not 3m plus 2. That only I want to say. In the textbook the question given is wrong. 3m in some textbooks the question given is wrong. 3m plus 2. It is not like that. In all the 3 cases we got. In the first case we got 3m. In the second case we got 3m plus 1. In the third case also we got 3m plus 1, not 3m plus 2. So square a square. Square of any positive integers comes in the form of 3m plus 1 or 3m. Hope you have understood, and about the mistake also I think have understood. Hence square of positive integer a. We have taken a as a positive integer. Hence square of positive integer a comes in the form of that is a is equal to 3m or a is equal to, sorry, a square, because it is square, a square is equal to 3m and a square is equal to 3m plus 1. Hence we have proved this. For this class